Hello everyone, I want to welcome you all to my talk today. And in this talk I'm going to be discussing continuous delivery, software development tools such as Git, and how combined they can help developers ease their software development practices as well as shorten their deployment and release cycles. Before we begin, I'd like to introduce myself. My name is Angel Rivera. I'm a senior developer advocate with CircleCI. And in my role at CircleCI, I engage developers and the developer community to understand how developers are using technologies and also some of the struggles or obstacles they face when using those technologies. I bring that information back to our teams at CircleCI so that we can incorporate our learnings into building better features that add value to our developers and customers' lives. So let's talk about how do we develop software before I get into continuous delivery, Git, and all the cool things that people are doing these days. I want to kind of start by discussing how we're currently developing software. It's a huge topic to cover in its entirety in this presentation, but I'm going to focus on software development practices and how we can build software a bit more efficiently. So let's start by stating the obvious. Software development is hard. Writing code is very, very difficult. There's a lot of demand. It's a very stressful profession. And, for the most part, we want to ease the pain within our day-to-day software development lives, so to speak. But as a developer, I often ponder, what's software's purpose? Asking myself this question kind of keeps me on my toes, right, about the purpose of what I'm doing, why I'm writing code. And my answer essentially to this question is software exists to satisfy end users' needs, right? And we do this by creating digital services and solutions that provide fast, reliable, consistent, and secure results. Some of these results can come in the form of data, transactions, and executions, etc. But, software essentially automates things. It facilitates digital representations of concrete objects and physically executed processes, such as turning off lights or turning them on, or shopping and paying for things online. There are many ways to develop software, some more favorable than others, but like other professions, tools are critical in getting the job done. Tools such as text editors, programming languages, and frameworks are examples of bare minimum tooling that every developer must have to build software. Software is designed to aid users in completing tasks and accurately mimicking human behavior digitally, and programming silicon to execute these behaviors is no small undertaking. Tooling aside, other elements of our software development, such as development concepts and methodologies, add to the difficulties of creating software. Although the difficulties exist, there is some light at the end of the tunnel. There are tools, concepts, and practices developers can adopt and implement that can lessen the difficult parts of software development. And I'm going to discuss some of those tools and development practices that developer teams can implement and benefit from. So let's start with Git and continuous delivery. They're a great pairing that provides great value when combined and implemented. If you're not familiar with continuous delivery, don't worry, I'll definitely cover it shortly. So let's start with Git. As we all know, Git is a versioning tool that enables developers to capture and version changes to code. Git is very popular with developers because of its small footprint and distributed architecture. With Git, changes can be developed in isolated branches, which prevents unwanted code changes or mistakes from being introduced to production-level branches. And we've all been there where we've unintentionally introduced either bugs or some shoddy code that we were just doing some experimentation with. I've definitely been there myself. So developers can safely experiment with code, minimizing the risks of polluting critical branches. And even if they do manage to corrupt the code base, Git is a version control system that is capable of easily reverting the code base to a safe state. Let's take a look at a manual Git development flow. So developers clone down repositories to their local environments, and then they begin writing code, right? They begin changing the code, making the modifications that are required or fixing bugs. Whatever they're doing, they're just writing code, and they're doing it locally in their development environments. When those changes are in a state where they kind of hit a milestone where they feel comfortable with those changes, the developer will then commit those code changes locally, and then when they're ready, they push those code changes to an upstream branch, maybe to a repo sitting in GitHub. And then their changes, once they're pushed up to that branch in the repo in the version control system, these changes are now available to their peers and open for code review processes. Now, let's talk about manual code review processes. This is, when I'm talking about manual, I'm talking about just the fact that developer teams will have a process to kind of review the code changes that are being proposed or committed before actually incorporating them into a production level branch. So once those code review processes begin, developers' changes are scrutinized for things like known bugs, errors, and compliance with maybe coding standards. Manual code reviews are helpful, but are very expensive, extremely resource intensive, and definitely prone to human error because, again, these are things that are happening again with human intervention. So if you look at the diagram there, the developer will get push the code changes up to a shared branch. The manual code process could start maybe an hour later. It could start a day later, a week later, a month later, whatever timing that is in a manual code review process. We don't know. Every team is different, but the general pattern is the same, right? So they'll do some review. If they find any defects, bugs, or errors, the code is rejected, and then the developer has to kind of start over, right? Pull down those changes and then start making the changes to the changes. Or the other way, which I call the happy pathway, is that the code is legit, it's fine, and it's accepted and then pushed to the main branch, which is then released to production. So again, all of this is manual and resource intensive, requires humans to actually do things. But one of the reasons why I say it's expensive is because at CircleCI, we've estimated that developers' time costs about $1.42 per minute. And that's $1.42 per minute US dollars. So if you do the math, 120-minute code review times 10 to 20 developers that are involved gets to be very expensive really, really quickly. And we can control those costs. We can also make those code review processes more efficient by adopting concepts such as continuous delivery and continuous integration practices among the teams. These practices enable developers to increase communication and build software way more efficiently. So let's take a look at continuous delivery, or at least a definition of continuous delivery. It is essentially the practice of building, testing, and delivering changes to code and user environments using automated tools. And the key takeaway here is using automated tools. Now, within a continuous delivery, we have other concepts such as continuous integration. And this concept essentially focuses in on the developer and the way that they build software. It's essentially a principle and a concept that can be adopted and implemented within software development teams. So the gist of continuous integration principles are that the developer will write commit code often, commit to a shared code repository, right? That's what we were talking about earlier about pushing code changes upstream to a shared code repository. Within continuous integration principles, the code is tested on every commit. And then one of my favorites is the fast feedback loop, right? So while you're implementing continuous integration, you have to have a mechanism to, check all those things, ensure that the code is up to snuff per your requirements or your testing regiments, and then provide the developer a quick feedback loop so that they can make those changes and fix whatever's wrong with the code as quickly as possible. And then that will also lend itself to helping decrease the time for code changes to reach your end users. So within continuous integration, the definition here is the practice of merging all developers' working copies to a shared code repository. And I think I stated that a little bit earlier. I also wanted to talk about continuous deployment real quick, which is another part of continuous delivery. And continuous deployment is the practice of automatically deploying new software releases to target environments. Again, we have that automation kind of vibe within these definitions. And combined continuous integration and continuous deployments form the acronym CI/CD, which is, I'm sure, what a bunch of developers listening to this talk probably have experienced or heard before, or maybe even both, hopefully both, because it is the way that the software development industry is going, right? Automating, implementing these concepts and principles to help build software more efficiently. So in any case, what I described within continuous integration and continuous deployments, or CI/CD principles, are really just that, the principles, right? The guiding statements behind, or directives behind these principles. But in order for these principles to kind of be realized, we need automation. Automation transitions CI/CD principles into reality by defining and executing software delivery practices or processes. So one of the ways that you can automate these practices and principles is by employing or adopting or implementing a continuous delivery platform such as CircleCI. And that's exactly what CircleCI does. We basically enable developers through our platform to realize or facilitate them making their continuous delivery practices and principles a reality. And we do that by enabling developers to build what we call CI/CD pipelines. CI/CD pipelines are essentially a grouping of things that need to be executed against code to ensure that the code is being tested properly, your artifacts or your deployment artifacts or binaries are being compiled properly, they're also being tested, maybe security scans, whatever it is that you need to do within your software development processes, you can automate using CircleCI within a CI/CD pipeline. And what I'm showing you here is an example of what a CI/CD pipeline looks like visually within the CircleCI platform. So let's talk about manual code reviews again. As I mentioned earlier, the software developer will create some code locally, then he'll push that code up to a shared branch. The manual process will start where that involves humans, scrutinizing the code, looking for bugs, maybe even using some tools to do that. It's very common. But at the end of the day, it's kind of in my opinion, a very kind of messy, kind of old school way of doing things, where you have more humans involved than you should. Now let's take a look at a happy path, automated code review process, right? So in this case, all of the previous inner workings, right, of a manual code review process has kind of been streamlined, right? This is the way it looks in an automated process. The developer, so the process or the actions are kind of the same, but what we're doing here is kind of, again, streamlining it by using automation. So if you get to the point where we're at the pushing the code up from the local development environment into the shared branch, CircleCI detects those changes, and then it starts testing the code, making sure everything's cool. And in this scenario, everything is pretty much hunky-dory. All the tests pass, all of the transactions and build jobs pass within CircleCI. And then finally, using this automation, the developers can then push those changes to a main branch, and then they'll be ready to be disseminated in the next release cycle. So I also want to take a look at that same process and show you what it looks like when you're using automation and how it fails. We're testing the code, and and using automation, and they're failing, right? Maybe 2 of the 3 things fail. We build a Docker image, but again, the pipeline has failed, so you don't want to deploy that code. But what happens instead is once the system detects that there's a failure, it will notify the developer that, hey, you have a problem with your code. And then, the developer will be quickly notified and then can start fixing the problem, so recover from those errors, and then run that whole process again. So the main point here is to automate manual processes, right? So this is one way you can reduce the amount of human resources involved in your code reviews, right? That's just one aspect of software development that you can leverage continuous delivery, continuous integration to help with, lessening your basically your release cycles, as well as increasing the reliability of the code, right? Some of the benefits of continuous integration, again, are the fast feedback loops, right? Knowing when something's broken and being able to jump in and fix it as quickly as possible. Code changes are tested and vetted every time, so that, again, you're producing the highest quality code that you can produce. You're increasing your collaboration around code, which helps also with team synergy, right? I know it's an overused word, but it's still a valid word where, your teams are actually functioning a lot better, communicating a lot better, and being able to stop or catch red flags before they actually happen, right? And in one case, maybe developers are, touching the same code. 2 different developers are touching the same code, or at least changing the same code. What I mean by collaboration is they can collaborate before they even start working. Like, they know they're going to have to touch some code. They can collaborate, like who's going to go first, and avoid these merge conflicts that happen all the time. And again, it improves that communication among the developers, which is really, really critical to operating efficiently. And then finally, right, it decreases your release cycles, meaning those code changes are going to get to your customers way faster under properly implemented continuous integration principles. So what I've covered here is continuous delivery, and in principles and in theory. But what I want to do in the next slide here is introduce a demo that's going to basically show these things in action and how easy it is to implement. Okay, so this demo is basically going to show a continuous delivery pipeline definition, or a config.yaml file. This config.yaml file is how CircleCI enables developers to define their continuous delivery pipelines. It's essentially a YAML definition, right, or data structure within the config file. There are some YAML keys that are specific to CircleCI execution. And YAML is a declarative data structure, which is why most current cloud native platforms use it to define configuration. And again, this is exactly what you're doing within the CircleCI config file, is defining your CI/CD pipeline, and you're also, I guess, configuring it as well. So the pipeline is basically going to do a few things. It's going to run some tests. It's going to build a Docker image. It's also going to create a GKE autopilot cluster, which enables us to deploy that built container. And then it's going to run some smoke tests in that application once it's deployed. And then finally, it's going to destroy that cluster because we don't need it anymore. So let's go ahead and execute a change. So the CI/CD pipeline needs to be triggered some way. The way that we trigger it is by changing files and pushing code upstream, because CircleCI is watching the upstream repositories and branches for changes. So what I'm going to do here is use Git Kraken to make a change. So my application is very simple, but I made a mistake. I need to run the port is misconfigured, and it needs to run on port 5000. So I'm going to go ahead and get Kraken and just kind of change my code. So let's open up the app.js file. I'm going to edit it here because, Git Kraken's a pretty cool tool. Then I'm going to change the port to 5000. I'm going to go ahead and save the file. So now that my change has been saved, I'm going to go ahead and stage it. So that I can then go ahead and push it upstream and kick off my CI/CD pipeline. So now that it's staged, I'm just going to put a message here is fixed port number. And then what we're going to do here is commit the change, right? So now I have this change locally. If we look at the change, we should be able to see what the change was. I changed it from 4,000 to 5,000, and then I'm going to push this. So this is going to trigger the build. So if we jump over to the CircleCI dashboard, the platform will go ahead and detect the changes, and then it's going to go ahead and kick off my CI/CD pipelines. And that's what that looks like, right? A visual representation I showed you in one of the slides. But it's going to take some time to run. So we're going to fast forward into, I'll be right back when this is all completed. So our pipeline has basically completed for the most part. And if you're looking at the screen and you're looking at the different components within my CI/CD pipeline, you'll understand that I've created a new GKE autopilot cluster, which is a Kubernetes cluster. And then the application has been deployed. So the pipeline has packaged up the application into a Docker image and then deployed it to our newly created GKE cluster. And then the application itself, right, is actually running. Now, if we jump over to, let's say, our Google console, do a refresh, we should see our new cluster, which is there. We also can look at the workload, which is basically our Node.js-CircleCI pod, which is running. And if we want to see the application actually running on this server, we just go ahead and go to the services where it created a load balancer so that it's externally available to the public. I click on this this pop-up here, or at least get the link address, and then we'll go ahead and populate that there, and we should see our application running. This is currently running again within the CI/CD pipeline and in this workflow. So what I wanted to show you here again or illustrate was the power of continuous delivery, continuous integration, CI/CD in general. But one of the things that also I wanted to illustrate was this highlights how you can automate kind of code review processes, right? Just automate the things. We're constantly checking for specific patterns within codes, right? So for errors and such, you can automate that with automated tests. You can do, automated compliance type scans. One of the things that I like to do here with this pipeline is, or show with this pipeline is that, just because you built an application properly or built a Docker image properly doesn't mean that the deployment's going to always go as planned. This pipeline actually verifies. So this is why I have a smoke test, which essentially tests that deployment. And what it does here is basically checks for the application to be up and running, right? These are simple tests. Of course, you can do more extensive testing, which I highly recommend, but do it, where it makes sense within your pipeline. In this case, I'm just creating a sterile Kubernetes cluster, deploying my image, and then testing to make sure that it works. And then finally, I don't need that infrastructure anymore. I'm going to go ahead and destroy it. So we have what we call a manual process within CircleCI. And then we just click that button, right, to approve the destruction of that cluster. And once I click that button, my job will execute this destroy command cluster, and then after a few minutes, this cluster that we created will be no more. And if we look now, it's probably starting to destroy itself in a few minutes. So basically, that's the tutorial or the demonstration, and it's also a tutorial, I guess. But I just wanted to demonstrate again the power of CircleCI, continuous integration, and how you can automate things so that your software development practices go a lot easier for you. They're more efficient, and you can essentially reduce your deployment and release cycles. Thank you very much for listening. And again, if anyone wants to reach out to me, my Twitter handle is @punkdata.
Hey, and we're back. Thank you so much, Angel. That was an incredible talk. Continuous integration. First time I've ever heard that. And I know I stumbled across that word, saying it a few times. But I really want to just jump straight to these questions that we got asked out on Discord. So Kevin out on Discord asks, what are the key differences, benefits of CircleCI versus just using something like GitHub Actions?
Oh yeah. So yeah, I get asked that all the time, by the way. So yeah, so the key benefits are, using CircleCI over GitHub Actions or any other kind of provider. Number one, we've been around for a long time. This year we're celebrating a 10th year anniversary. But beyond that, well, with that, I guess that age comes some experience, right? So we've been doing continuous delivery, continuous integration, continuous deployment for a long time, and that gives us basically a lot of information on how to build our platform, how to make it better, and that's exactly what we've been doing, right? Taking those learnings of how people are building on our platform and creating a very robust experience for our developers to get their stuff done as quickly as possible without having to manage infrastructure, right? Even though like GitHub Actions has those capabilities, they don't have as many capabilities as we have, right? And features that kind of help the developer workflow, right? Whereas, for instance, we have capabilities that offer our developers, very fast run startup times for our executors, right? Our machines that run the jobs for folks. So it's a lot about speed, right? All about CI/CD and continuous delivery is about speed. Being able to deploy things, being able to figure things out as far as like, are the changes I made, are they good? Are they not, right? And getting that fast feedback loop. We also, like, again, we're best in breed. I mean, there's not a lot of folks with our experience have been around as long as we have, and yeah, there's also features like SSH, right? So if you're debugging, you can debug, your developers can actually debug their problems in the executor, in the environment where their builds are failing, right? On other platforms, you can't do that, right? They just don't have that capability, and we've always had that. So there's just things that we know that the other folks don't know. And I will say this to close it all out: CI/CD in those other platforms, for the most part, are features, right? They're not really thought out and built in, right? Like GitHub is a code repository, and they bolted on, right, the CI/CD piece, which it shows, right? It's great, yeah, that it's nice and kind of packaged, right, with the code, but there are some very, very when compared to CircleCI, it's very limited in what it can do. And again, all we do is think about CI/CD all day, all night, which it shows in the product and how we can scale very, very easily. And yeah, we don't bolt it on. We are best in breed, and we think about CI/CD and how to make our developers' lives easier versus adding a feature because your competitors have other competitors' version control system added there, had a better CI/CD feature set.
Yeah,
So that's the differences.
I think that that really speaks to the heart of it. You said you test out on your actual environments, and that's, I know, a headache for a lot of folks of testing out in a virtual environment. You can set a development environment to be as close to production as humanly possible, but it's not your production environment.
Exactly.
Even if you're cloning it 100%, just test, and as many times as you can test it.
Yeah. And I'll just add that, I always tell folks, in a normal, world, especially if you're working in large organizations, developers basically get roadblocked because they don't have permission, right, to do things. They don't have that self-serve kind of feel. With CircleCI, we're all about self-serve, right? We're trying to eliminate all those barriers. So if you need to debug in the environment where your builds are failing, you don't need to contact your security people or system admins or SREs or whatever. You can just do it, right? And then fix your problem and move on with life versus, oh, I need to debug on XYZ executor, I need permission, or I need this and that, even if those capabilities even exist, right? So that's kind of like what we're trying to do, is again make the developer's life easier by adding all this automation and the capabilities within that automation to even facilitate more ease, right?
Right on, man. Uh, Moving on. So we got another question
Yeah,
here
yeah.
from Kartik Gupta out on Discord. And that kind of, you started talking about it right there. How do you suggest we manage build times when we have 50 plus developers committing changes to 50 plus branches on any given workday? That's quite a lot of branches, a lot of commits.
Yeah, one of the ways teams can, kind of manage it, because once you start adding those kind of builds, you just have to kind of take a step back. A lot of folks, unfortunately, equate the tooling of, like, CI/CD tooling, whatever it is you're using, CircleCI, GitHub Actions, GitLab, whatever you're using, to implement an implementation of continuous integration, right? So that what I'm trying to say is, I see this all the time where teams don't really figure out a in principle and in practice their CI/CD plan, so to speak, right? How they're actually interacting with the code, instead of equating that with the tooling. They think like, oh, we just implemented, whatever, CircleCI, and or we implemented GitHub Actions, but it's not quite working out, right? So what I'm trying to say is they don't really reflect their software development practices in their CI/CD uh, uh, definition. You know what I mean? So first, my advice is start with formulating and implementing and adopting a proper CI/CD, or CI. Let's talk about CI practice within your developers, right? So what that means is, yeah, everyone should be, committing code to a shared branch, right, as often as possible. Whatever that looks like, could be twice a day, 3 times a day, right? Just pick a number, pick something that makes sense. And even if it's a small number, I would say at least once a day, because you're not really doing continuous integration in my mind if you're not, continually updating something. So that's where I would start, is look at your internal practices, because I hear this all the time, like, okay, we switched from I don't know, GitHub Actions to CircleCI because we found that it was too slow, and then they're basically complaining to me that it's still the same problem. And then I start digging deep and asking them, okay, so what is your plan? What are your processes outside of the tool? What are your processes? How does your team collaborate around code? And they have no idea what I'm talking about. And then I tell them, well, that's actually the problem. Just because you switch tools, you still have the same problems now, but in a different tool. So my advice is, first get with your team, figure out a plan, right? And start small. Don't try to tackle all of the things at the same time. Just put the top 3 things that are kind of like blocking everyone, and try to, create some sort of process around that everybody agrees with, that everybody can follow, right? And then as soon as that starts getting adopted, you'll start seeing that interaction and collaboration around code within your practices, and then you can build pipelines that reflect, right, those practices in your workflows, right? So and then that will help you scale, manage the 50 plus branches and developers, and right, it'll help you scale all of that work, and then also create some sort of monitoring, which we actually have in CircleCI. We have a what we call an insights dashboard. So let's say, like, an engineering manager can say, all right, my team is flowing along nicely, they're building, pushing, and we're getting results and feedback, and then you can start seeing trends, right, within your team, like, all right, we're starting to see our velocity increase. And maybe even when your velocity increases, you start seeing some bottlenecks, right? Maybe some failures. And then you can pinpoint as a manager and go, okay, we're seeing failures, and it's occurring in a specific build of what, let's say maybe it's a Java stack, and maybe you introduced a new dependency. And you know what I mean? That will just kind of do a little bit of forensics and help kind of red flag things. And maybe the new dependency either has a problem, or maybe your developers just don't know how to use it, right? So that'll kind of surface all of those things that will help increase, get rid of those blockers, and then increase your velocity, or maintain your velocity, however you're, defining that. So yeah, there's a lot to it, and it's only getting better, right? I think there's like a lot more use cases and cool elements to this automation that are going to be exposed in the next in a couple of years and next couple of months.
It's just amazing how far it's come in such a short time. I remember the first time I
Yeah.
ever saw CI/CD in action it was probably 2015, 2014. And it just
Right.
blew my mind. It's like, this is, well, somebody described it as cron with a bunch of shiny knobs, which kind of is an accurate statement, and it kind of really undersells what's going on.
I think the initial offerings, like I remember when it was called Hudson, and right, like Jenkins was called Hudson, and that came out. And yeah, at that point, I would say, yeah, it was kind of, I used to say it was like a cron on steroids, right? But now I think it's beyond cron. Right? Obviously, we're kicking off and triggering and executing things, not on a timed basis, but more of a, hey, this is an event that occurred, and now we're going to triggers this transaction to, or execute this pipeline via a push, right? Git push is usually the trigger, and at least in CircleCI.
We got time for looks like one more question.
Yeah.
And this is a very specific question to a use case around, well, I'll just read it. If there is any way to automate a sheep ear tag lookup since it uses external hardware, where's the context on that? If you need more context, my code has talked to an RFID tag reader, and then does some things based on a database lookup of a particular animal. It's a sheep ear tagging system, use external hardware. Is there a way to automate that using something like CircleCI? I think the bigger question there, and this is what I answer a lot of use cases, is can you talk a little bit about like Internet of Things and any use cases about people doing that?
Yeah, absolutely. So, obviously, if you have an Internet of Things application, right? So that means if he's talking about specifically sheep. So I actually have experience in this. The previous startup I worked for, we were doing Internet of Things, so I can kind of assume some things about this question. But my assumption is, he has a sheep ear tag. That means he physically has sheep somewhere and they're all tagged. And he probably has a sensor, right, living in the pen where the sheep are or where the sheep live or whatever. At the end of the day, as long as that, reader, the RFID reader, is returning those tag numbers, usually, the RFID usually only has a serial number. I've actually written solutions for RFID. So if those things are returning, right, and being captured a specific time, so usually it's like, hey, this ID was read at X time at this location, then the idea there will be that once that data is captured, and there probably is some sort of edge solution, so an edge service, right? So that means there's probably some sort of compute node somewhere in that vicinity, or maybe in the barn, and then that's backhauling, right, that data to a log somewhere and then associating it to a database. If you have that situation occurring where the data is being backlogged into a database, you can easily create and depending where your database is, if it's in Amazon S3, or not S3, but in Amazon's was it DB, what is that service? It's slipping on me.
I know what you're talking about, and I can't think of it either. I once got charged a lot
of
money.
Wherever the database lives, right? So if it's behind, let's just take, for instance, behind a firewall, right, on premise somewhere, we have an option or a feature called CircleCI Runner, where you can actually spin up inside of your infrastructure, through the cloud pipeline. You could have this machine running in your pipeline or in your infrastructure on-prem, removed from our cloud. That is essentially an executor, right? So basically what that does is you have an agent that calls back to the cloud, and then the cloud will offload workloads to that specific runner. We call it runner. And all that runner is doing is just executing work in your infrastructure, in your segmented, protected infrastructure, so that if you have a database that's in that same network, then that runner can make a call just like normal and do an SQL call, right, and bring that data to whatever, format it however you want and save it as an artifact to your pin build. So that's how you would get around testing. I'm just making assumptions here about this specific use case, which sounds like, pretty spot on. But yeah, you can definitely, that runner could have even the drivers to call your hardware, right? So, you know what I mean? Like there's ways to get around it. And it's all kind of isolated in your environment, but the pass or fail of that test will show up in your cloud, right? So if you have everything running, we tell people to use the runners if they have instances where they're kind of like in a hybrid situation where they have these things, requirements that they can't push data outside of their network. But what they can do is run tests, with these runners within their networks, and then just say, hey, CircleCI, this test passed, right? My pipeline passed, or fail it if it doesn't work, right? So there's ways around it, and I'll be more than happy to walk somebody through, if they need a little bit more, more details or exploration of that.
Well, unfortunately, that's all the time we have for questions, and we got to move on for the rest of the event. Awesome. But thank you so much, Angel, for joining us.